All right, welcome to lab number 3 on multiple regression. So just like lab 2, for this lab, the questions are the same. So here there are actually 3 questions and 2 points each, all right? But for the purposes of the in-class demonstration and the purposes of this video demonstration, I will be using data from the data for class tab. But when you submit the lab, you are using data from the data for home tab. Again, the answers may or may not be the same between these two data sets. All right. So again, I'm using the same questions, but data from the data for class tab. And this is just let me explain the data sets. So I am a stationery store, right? Stationery. And I have one location in each US state. All right. And so I have one location in Alabama and one in Alaska and all of these wonderful US states. Just one location. And each location can be classified, the building height as either high, medium, or low, medium, or high. Here is the number of customers that come into my store a month. Here is how much I spend on advertising pens a month, how much I spend advertising pencils a month, how much I spend advertising markers, crayons, erasers, and other products a month. All right. So in the state of Alabama, that one store is medium in height. 4,560 customers come into the store a month, and I spend $59 on pens, $39 on pencils, $47 on markers, $10 on crayons, $7 on erasers, and $4 on other. So we don't need to fill in any data, so that's good. Let's look at the questions. Now, before you do that, make sure that the data analysis or the analysis tool pack is installed. We went through this in class. If you've forgotten how to do it, you can search for it online, or please email me and I will remind you how to install the analysis tool pack, whether you are on a Mac or on a PC. Question 1. For buildings high in height, which advertising expenditure best predicts the number of customers? If there is more than one, identify the one that is the best predictor. All right, I'm using data from the data for class tab. I need to go to height, filter it to high. I'm going to copy this table and paste as values to a new sheet. So I have a very clean sheet. It's just showing me data that's high in height for buildings that are high in height. It's not hiding data that's for buildings medium or low. It's showing me a clean sheet. I am now going to run regression. Go to data, the data ribbon, find data analysis on the top right corner, find regression, click on OK. Now the Y range. What am I predicting? The dependent variable. I am predicting the number of customers that come into my store. Customer information is in column C, so I select that column. Manually select C1 all the way down to C18. And it should automatically populate with $signs C1 to C18 in the input for Y range text box. In the Y range, in the X range, what am I using to predict the Y? I'm using amount of spent on advertising pens, pencils, markers, crayons, erasers, and other. That's in column D for dog, D1 all the way down to I18. Columns D, E, F, G, H, and I. Select those columns. All right. Next, select labels, the tick box labels. Keep everything else as the same. Just click on OK. And these are the results. Now, look at the p-values. Which ones are significant? As in which ones are 0.05 or less. In this case, there are 2 p-values that are significant. Markers and erasers, 0.05 or less. Markers is 0.03, erasers is 0.002. They are both 0.05 or less, and that's all we care about, if it's 0.05 or less. Then focus on the coefficients. For markers, it's 6,422. For erasers, it's 1,507. Which one is the best predictor? It's the one that is highest, that is the larger in value in absolute terms. All right. So in this case, markers 6,400 is a much bigger number than 1507. So the answer is markers. All right. Question 2, for buildings that are medium in height, do the same thing. Which advertising expenditure best predicts the number of customers? I should also mention this about markers for question 1. Markers, the coefficient is 6,422. If I were to interpret this, what this means is that for every $1 increase in the amount I spend on advertising markers, the number of customers go up by 6,422. For erasers is for every $1 increase in the amount I spend advertising erasers, the number of customers will increase by 1507. So it's always for every 1 unit increase in X, Y goes up by the amount that's stated in the coefficient. Let me say that again. For X, but it's pens, pencils, markers, and erasers, but well, in here, it's only markers and erasers that's significant. For every 1 unit increase in X, for every 1 unit increase in the amount I spend advertising markers, the number of customers, the Y, the dependent variable, goes up by that number that is the coefficient. That's how I interpret this output. Now let's do the same thing for medium and height. All right. Filter to medium and height. Copy and paste as values to a new sheet. Data analysis, regression. Select column C for Y, columns D, E, F, G, H, and I for X range. Make sure labels is ticked, as it just so happens, because it's kind of using the same information from the high, the previous time I ran this regression when it was high data sets. So I technically don't need to change anything. Labels is ticked, click OK. Look at the p-values. The only p-value that is significant is other. If you see an E minus right there, 3.95 E minus, if you see an E minus, it means it's an incredibly small value. So it's definitely less than 0.05. And so there's only one p-value that's significant, and it's other. So the answer is other. There's no need to compare the coefficients, unlike question 1. All right, question 3, buildings that are low in height. Same thing. Filter to low in height. Copy and paste as values to a new sheet. Do a regression. Everything is filled out. Again, it's just like before. You might need to do it manually again, but on my computer, you don't have to. Labels is ticked. Click OK. And the only p-value that's significant here is markers. On my computer, it's 2.56 E minus. All right. Now, 2.57, actually, 2.57 E minus. Once I start blowing it up, so I blew this up, now it changes to 2.6. It's just doing a rounding thing. 2.57 round up is 2.6, right? But as long as I see a E minus, it means it's an incredibly small value. It's just too many zeros. It's 0.00000, a lot of zeros and then 1. There's too many zeros to fit into that cell. That's why it's an E minus. And only that value is significant, markers. All right, so we don't need to compare the coefficients. And the answer is markers. And there you go. Question 1, markers. Question 2, other. Question 3, markers. Now, remember, when you do the lab, you're using data from the data for home tab, but the instructions are exactly the same.